4.2 is about the mean value theorem. For this section, there are two things. Number one is about the Rolle's theorem. And number two, the mean value theorem. Mean value theorem. And these two theorems based on the common things as the first one, the function has to be continuous. Is continuous on the closed interval AB. Both of them have the same condition here, or we call assumption. Fx is continuous on AB. And then the second assumption that they have in common, f prime is defined. Okay, f prime is defined. Well, f prime is defined. The other way we can say f of x is differentiable. That means you can find the derivative on an open interval, not the closed interval, because we don't count the two endpoints. Same thing. So fx is differentiable on an open interval. Same two conditions. And then, so for the Rolle's theorem, they have another assumption that for the mean value theorem, it doesn't have it. The one that Rolle's theorem has would be the function value at point A equals the function value at point B. Okay. If these three assumptions met, therefore by the Rolle's theorem, they're gonna be the point C that the f prime at C equals 0. Okay, f prime at C equals 0. So the point C and C is on an open interval AB. That means we don't count the two endpoints. For the mean value theorem, you don't have to have the FA equals FB. If they are the same, it's going to go back to the Rolle's theorem. And basically, the Rolle's theorem is, I would say the mean value theorem cover in general, but the Rolle's theorem is just the special case of the mean value theorem. And the assumption of the mean value theorem is going to be some point C, at least one point C on an open interval AB, similar way as the conclusion of the Rolle's theorem. But this one, it will say the slope of the secant line. That means you're gonna have the two endpoints, find the function values, right? And then form the slope of the secant line equals the slope of the tangent line at the point C, where C is on an open interval AB. They work on the slope of the tangent line, but for the Rolle's theorem, the slope is 0. For the mean value theorem, slope could be anything, but the slope at that point must be the same as the slope of the secant line passing through two endpoints. Okay, so for the graphical way, for the Rolle's theorem, you have point A here, point B here, and you have the graph. By assumption of the Rolle's theorem, point A, point B has to have the same function value. So gonna be, and the graph is continuous. That means you have the smooth curve. Whatever the graph goes, it has to be one smooth curve. Okay, it has to come back to the same spot by the assumption of the Rolle's theorem. And then since the FA equals FB, the graph is smooth or the graph is continuous. Why I say smooth? Because the f of x is differentiable. So this part gonna tell you about the property of the graph, that the graph is smooth, okay, between A and B. So there is the point C in between that has the slope 0. So right here, f prime at C equals 0. Okay, it could be more than one point C as long as the slope is 0 and the C is somewhere between A and B. We don't count point A, we don't count point B. It has to be in between. So this is the summary of the of the Rolle theorem, Okay, and then for the mean value theorem, the graph, point A, point B, but the function value not necessary to be the same. So if this is a function at A, this is a function at B. So you have the graph, for example, start here and could be somewhere and then come back here. All right, come back here. See function value at point A and point B. And there is the point C that has the same slope. First of all, draw the secant line passing through the two endpoints, point A, point B. Okay, so this dotted line, the M, which is I call it M secant, is from FB minus FA divided by B minus A. It's going to be the same slope as you draw the tangent line at some point on the graph. So this tangent line. So over here, it occurs at the point C and C between A and B. The depth prime at C can be found, okay, and it's the same as the slope of the secant line passing through the two endpoints. So this is a summary of the mean value theorem or the section 4.2. Questions?
The mean value, the A F is continuous on the, it's a closed.
It's a closed, yeah, it's a closed.
Oh, okay.
This one,
Yeah.
yeah, thank you. Sorry for my handwriting.
Go
Yep,
ahead.
the first condition, it has to be continuous on the closed interval. But the differentiable part, it has to be within or it has to be interior points. Because at two endpoints, it's just one-sided differentiable. That means it has only the right side of one point and the left side of the other point. Since we are looking at just the certain interval, not outside of it.